Hello and welcome back to the Data Science Daily series. And I'm very excited to have you back again. Today we will be continuing our discussion on comprehensions in Python. Just a quick recap, what all have we covered in the Python bootcamp so far? We have talked about data types and we've talked about the different operations on data types. After that, we segued into the for loops, the while loops, and the conditional statements like if, else, and else if. Post which currently we are in the comprehensions session. We are covering the third part of the series, and this is the final part in the comprehension series. We have covered what are comprehensions, what are the different types, which is list, set, and dictionary comprehensions. How do you add conditional statements to comprehensions? This was covered in the last video. If you have not watched till this part, make sure you're going back and watching those parts before coming here. Because today we will be discussing a very complex topic called nested comprehensions. And we will also look at some basic functions which are inbuilt in Python, which are quite powerful. So without any further ado, let us get started and make sure you have a Python notebook handy so that you can also follow along in class and experiment along with me. Okay, so what are comprehensions? A very quick recap. These are a powerful way to concisely create and manipulate new data structures like lists, sets, and dictionaries because these three data structures are mutable. They offer a more compact and often more readable alternative. And they can be enhanced with conditionals to filter or modify elements. You can use the if condition, right? You can use multiple if conditions, right? If you want to filter for multiple conditions, you can use the if else condition, right? And you can also add more than two conditions, right? You can add if, else if, else if, else if, as many times as you want it, and then finally else. The main distinction between using only if conditions and using if else or even if else if else, this kind of a structure, is that if you're only using the if conditions, they always come towards the end of the comprehension definition, wherever you're defining a comprehension. Whereas if you're using an if else or if else if else, this kind of a structure, it comes in the beginning, just after the expression, this will come, right? And then the for part of the statement will come, or the comprehension will come. So a very important thing to keep in mind. Now let's move forward. Let's talk about inbuilt functions for loops, right? Which are very relevant for loops, and these are inbuilt within Python. The first one is the range function. The purpose is to generate a sequence of numbers within a specified range. And what the syntax is, there are three arguments: start, stop, and step. The stop is the only required argument, right? So if you mention range of 10, start will be mentioned as 0. It will be defaulting to 0. Step will be defaulting as 1. So if you mention range brackets 10, 10 will be assigned to stop. If you mention range brackets 1 comma 10, 1 will be assigned as start, 10 will be assigned as stop, and step will automatically be 1. And if you're giving three arguments, start, stop, and step, accordingly in that order they will be defined. Now let's see an example. For num in range 5, print num. Now what's happening? Range of 5 basically automatically understands that 5 is the stop, start is 0, and step is 1. Step is basically, how often it is skipping the elements. So here it's 1, which means it's not skipping any element. Start is 0, right? Because remember, if you start range 0 comma 5, 0 will be taken because the first kind of the value is 0, second is 1, 2, 3, 4, and then 5 is not counted. The end index is not counted, right? As with most functions within Python. So if you do this, you will get 0, 1, 2, 3, 4. And notice how this is so useful. If you want to, let's say, create a custom range and you want to print elements within it, you can just use the range function. Now I'll take another example where we are defining the start, stop, and step. So you're defining start as 1, stop as 10, and step as 2. So it will start from 1, it will step by 2. So it will start from 1, then 3, then 5, then 7, then 9. And then it will not go beyond that, right? Because the ending is 10, right? So it will never go, it will not even touch 10, right? It will always be before 10. So that's why you get 1, 3, 5, 7, 9 when you're printing this. So this is the range method or the range function, right? It's a function. because it's not applied to any object. A method is actually applied to an object. Now, the second function is enumerate function. The purpose is to add a counter to an iterable and return it as an enumerate object. Basically, whenever you're going through the elements of any data structure in a loop, if you want also to add a counter that this is the first, this is the second, this is the third, this is the fourth, enumerate actually helps you basically do that. So it takes two arguments, the iterable, whatever you are iterating over, right? And the index, right? The start base, the start value. So if it defaults to 0, right? So the first element in any data structure is always mentioned as 0th index or the 0 value. The counter value is 0. The second element has the counter value 1 and so on. So what this start enables you to do is, let's say you want to have the starting counter as 2 and then you want to say, so the first element in your data structure, you want to assign it the counter of 2 and then you want to keep on increasing, right? So you can also do that. In certain use cases, it might be helpful. But generally, we don't use the start argument as is. We just let it default to 0 for most cases. Now, I've defined a my list, apple, banana, cherry. And now I'm saying for index comma fruit in enumerate my list. Now, notice this syntax. I am mentioning two variables when I'm going through the for loop, index comma fruit. Because enumerate is actually an enumerate object which gives you two kind of values. One is the first one is the index, second one is the element from that iterable itself, which is in my list. Basically, the first element is apple, so fruit will be assigned to apple and index will be 0 because the start is 0 by default, right? And you keep printing that, so it will be 0 apple, 1 banana, 2 cherry, and that's what exactly is printed. And I've also formatted this, right? So it's not printing index and fruit by itself. I'm actually formatting it in a f string. So this is the enumerate function, and make sure you are understanding what is happening, right? Now, okay, we have covered range and enumerate functions. Now, the next step is to understand how to use these, and what we will focus on is nested comprehensions now, right? So nested comprehensions examples will actually take use of a range function a lot. Enumerate will not be covered as examples, but make sure you are remembering the syntax for future use. Okay, now let's come to nested comprehensions, right? Data structures within data structures. Now, comprehensions can be nested to create complex data structures. And here is where it gets interesting, right? So if you are comfortable with this session, it means you have reached a certain level of expertise in Python. If not, make sure you are watching this session again and again and understanding every single part of the code, right? This is the building block of your learning journey. So first thing I will try to do here is to create multiplication tables. And I want to create multiplication tables for 1 to 5, right? And I will take it till 10. I will multiply each number till 10. So 1 into 1, 1 into 2, 1 into 3 till 1 into 10. Similarly, 2 into 1, 2 into 2, 2 into 3 till 2 into 10. Now, how do you do this without using a comprehension, right? So this is the code. I have used a magic function, right? You don't need to worry too much about this. I'll just tell you the why we are using this. This is going to actually capture the wall time and the CPU time for the execution that occurs within this Jupyter cell, right? So if you add this magic function, the code will run as it is, but it will also give you a time that this is the time it took to run the code. The CPU time is basically how much time the CPU was running, and the wall time is the total time, right? So let's see, we will also track this and compare this against comprehensions. Basically, like, are comprehensions faster? Are the regular methods faster where you are writing multiple lines of code? How is it looking like? Now to the solution. So I'm defining an empty multiplication table, and I'm saying for y in range 1 to 6, because remember I'm using 1 to 6 because 6 will not be counted, so I'll get numbers 1 to 5. I'm defining a subtable where I will store the entire multiplication table for each number. So starting with 1, so I will store the entire multiplication for 1 here. And then basically I will again do an iteration range 1 comma 11. So it will go 1, 2, 3, 4 till 10, right? Because 11 will not be counted. And I will append to this subtable x multiplied by y, right? So I do that. And finally, when this is done, when I have the entire subtable list, which is 1, 2, 3, 4 till 10, these elements, I will append that sublist to the main table, list, which is multiplication table, dot append subtable. So this will become a list of lists, right? And you can see this is a nested data structure. And this is how it will look like. The time it has taken is 4.77 microseconds, right? And this is the multiplication table. Now let's see the method with comprehension, right? One line of code, right? So you're creating an inner list. So I'm saying, so I have this entire list comprehension. Now within that, I'm saying x multiplied by y for x in range 1, 11, right? For y in range 1, 6. Now, how is this working? I'll take this very slowly. So in the outer comprehension, right, y is ranging from 1 to 5. So first y value is 1. And then within this expression, this is itself a nested, or it itself is a comprehension, right? So y is 1, and then x is varying from 1 to 10, and you are multiplying x multiplied by y. So you will get 1, 2, 3, 4 till 10. Then, right, it is not completely evaluated yet. It will need to go to the next y value, which is 2. So y will go from 1 to 2. And then for the value of y as 2, it will again compute this, right? X multiplied by y for x in range 1 to 10, 11. That is, it will leave out 11, keep 10. So it will again compute 2, 4, 6, 8, 10 till 20, and so on until y becomes 5, and it finally computes the multiplication table for 5 as well. So in this inner list is actually a proxy for our subtable list, right? But you can see that you don't need to do any append, anything. It's just doing it for you. And it is taking even lesser time, 3.81 microseconds, right? Okay, so this is understanding the basic idea behind nested comprehensions. How can you nest lists within lists, right, using a comprehension? So this is the method to do that. Okay, let's look at a few more examples to become familiar. Filtering elements in a nested list. So this example iterates through a nested list and creates a new nested list containing only the even numbers from each sublist. So this is the list of lists that you have, and what we want to do is we want to create a new nested list, right? New nested list. So it should again be a list of lists, which only contains, right, the even numbers in each sublist. So what I want to effectively do, I want to take this list, and then I want to filter out the non-even numbers from each sublist and just return the remaining part. Okay, so the method without comprehension, right? Again, you create an even numbers empty list. You take the sublist within this data, which is the list, right? For each of that, you basically create a filtered sublist, empty list, right? Basically, which you will append. You need to create a list of lists, right? So the inner lists is what you are initializing here, the filtered sublist. And then you are going through each original sublist. You're seeing if it is divisible by 0, and you're appending, if that element is divisible by 0, you're appending it to the filtered sublist. And finally, once this is done, once you have for the first sublist, you have only the elements which are divisible by 0, you append that filtered sublist to the main final output list, which is even numbers, right? So let's actually run this. It's giving a wall time of 4.77. And this is how it is looking like, right? 2, 4, 6, and 8. It's a list of lists. Now, how do you do this with comprehension? With comprehension, you can simply do x for x in row if x is divisible, right? For row in data. Now, for each sublist in the data, for row in data, I'm defining it as row, right? You can also say sublist. So let's just make this sublist for ease of readability. For each sublist in the data, basically create one more list where you're iterating over the items in that sublist and finding out if they are divisible by 0, and only appending them if they are divisible by divisible by 2. Sorry, right? So if they're divisible by 2, you only keep them. So you create a list of lists like this, and you get the same output. I hope this is very, very clear so far. If not, make sure you're going through this code slowly very, very slowly and understanding and running this, experimenting with this, and coming to a conclusion that this actually works. Okay. If there are any doubts, make sure you're clearing them before moving forward. Now, creating complex data structures. Right? This is another kind of an application. This example creates a Cartesian product of elements from two iterables. So you're given two iterables, you want to create a Cartesian product, like all combinations basically, using nested comprehensions. So the way to do it is, right, so the basic way would be define an empty list for y in AB, for x in 1, 4, basically append all the combinations. Right? Basically, you will create a list of tuples because you're appending tuples, right? It's in a parenthesis. Now, the method with comprehension is that you simply define xy, and here is an interesting part. You're using two for loops, right? To create a nested list, now you're not defining a list within a comprehension directly. Like here, what we were doing is we were defining this inner list comprehension within the main list comprehension. Here, instead, what you're doing is you're defining two for statements. So x comma y for x in this, for y in that. So remember, first y will be fixed. So y will take the value of a, and then, okay, that's not the case, sorry. What will happen is, first, in this case, since there are two for statements, the first for statement will take priority, right? So first x will become 1, then y will become a and b. So it will be 1 comma a, 1 comma b. Then x will take the value of 2, and then y will vary as a comma b. So 2 comma a, 2 comma b, and so on. So if you see this, this is how it will look like. And we have created a complex data structure, a list of tuples using a simple comprehension of one line, right? So this is the power, and you should be very, very familiar with this. Now, one question which might come to your mind is, okay, the wall time is not very good. I mean, it's 1 microsecond more. So if you just think about the percent, it is 25% more than what I did. But the thing about wall time is it's not a very, very important metric right now, right? Because this is varying a lot. The time is very, very small. So if I run this again, this becomes 3.81, this becomes 5.96, and this still stays at, let's say, 5.25. So in this scenario, it is slightly better, right? So it will vary, but if you have a large code base, in that case, it's very important to measure the time, because if you can make your code efficient by using different techniques to get the same output, you should use the more efficient technique, right? Okay. Transforming elements based on conditions is the next one. Now, I want to create a list of adult students which contains the name of students whose age is greater than 18 with an A grade, right, by applying nested conditions within the comprehension. Now, this is my students kind of a list which has dictionaries within it. For each student, there is one dictionary which is telling us the name, the age, and the grade. And what I want to find out is find out the names of the students, right, who have age greater than 18 and have an A grade. So the simple thing I can do is I can create an empty list first, which is going to be my output list. For student in students, if age is greater than 18 and grade is A, basically append the student name. And I will get this. Now, what you can do is using comprehension, you can say adult students is equal to student name for student in students if that condition holds true, right? For student in students, will basically give you a dictionary, and then within that dictionary, you are basically checking if the age is greater than 18 or if the grade is equal to A, and you're retrieving the student name. So you're getting the same output, right? Okay. Now, one of the last examples here is flattening nested structures. Now, what we will do is we will try to flatten out a nested list by iterating through the sublists, right? And including only elements that are not lists in themselves. So if you see this nested list, this is a list of lists, but each sublist is also a list of lists, right? So this is the first sublist, or first element is actually a sublist, which in itself is containing 3 elements, out of which the third element is actually a list again. It's a sub list, right? How do you flatten this out? And we will be ignoring these kind of sub lists for now, like 3, 4, 8, 9. We will be ignoring for now. We just want to keep the remaining ones and just create one list out of it. We don't want a list of lists anymore. We just want to create one list with just the elements. So method without using comprehension would be create a flat list as an empty list. Then you iterate through this for sublist in nested list, right? For sublist in nested list, because we know this is a list of lists, for item in sublist, right? For each item in the sublist. So the first item is 1, second is 2, third is 3, 4. If that item is not a list, right? For example, here 1 is not a list, 2 is not a list, but 3, 4 is a list. If it is not a list, then basically you append that to the final expanded kind of flattened out kind of a list, which is flat underscore list variable, right? Otherwise, basically you go back, you skip that step. So if it is a list, like 3, 4 will be a list, you skip it and you go back to the top of the loop. And if this loop, inner loop is completed, you go back to the top of the outer loop, and then you go to the next sublist. Basically, you keep on moving forward. So what will happen is sublist will take the value of this first, what I have highlighted. Then item, it will get iterate through. So first it'll take 1, it will append 1. It'll take 2, it'll append 2. 3, 4, it will skip because it is a list in itself. It will go back to the top. The for loop has been completed for this instance. It will take the next sublist, which is 5, 6. And again, it will iterate for item within sublist, which is 5 and then 6, append those. Move on to the next sublist, come back to the top of the outer for loop. 7, this will take this sublist, and again iterates. 7 will be appended, but 8, 9 is again a sublist, sublist. So this will not be appended, right? Okay, so this is what you would see: 1, 2, 5, 6, 7. Now with comprehension, right, you can simply do item for sublist in nested list. So for sublist in nested list will come first. For item in sublist will come second in this list comprehension. If not this, right? If not this. So just a very, very interesting kind of way to remember this is you're starting from the last one here, right? So you're saying item, and then you're saying for sublist in nested list, for item in sublist, if not this, right? So that's exactly what we are adding here. And if you run this, it is giving you the same output. Now, one last thing, one last caveat is, let's say you want to add all the elements. You don't want to exclude the sub lists. You know it goes only 2 levels down. So you have a list. Within that, you might have lists, and within those lists also you might have lists. So you know that it goes 2 levels down. If you know that, right, what you can do. So what we were doing earlier is we were just saying, if not instance, then append the item. But what if that is actually a sub list? What do you do then? You can have an else statement then. So if it is a sub list, right, then for item underscore sub in that sub list, you basically append those items or those elements as well. If you do this, you will get all the numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So these were the numbers. We are getting all of them using this particular code. The only thing I've added is an else statement where you are dealing with an item, right? The variable item is a sub list, right? It's actually basically a list in itself. So you need to iterate over the item sub in that list, right? And append that item sub. So you will get all of these values. These are just few examples. There are a lot of examples, and this gets very, very complex very, very quickly. But the idea is take these problems, think about them, and try to solve them by yourself using comprehensions, right? And think about how you would solve them. So just take the questions, try to hide the answer, and solve it yourself. If you have any questions, feel free to put them in the chat. I will be getting back to you as soon as I can. I hope you enjoyed the session. This was our concluding session on comprehensions. Next, we will discuss some more interesting topics. So stay tuned, and I will see you again.